and just go straight to it, yeah, you could do that. I mean, it's really, at this point, it's whatever you feel most comfortable with. I look at that, I think U sub, but you could go to the other trig functions if you want. So I'm going to write down the basic U sub I'm doing here, right? I'm replacing sine theta with U, and then the derivative of that sine is cosine theta d theta. So now I'm going to rewrite this new integral in terms of U, right? What is cosine theta d theta replaced with? What's that top? That's just du. So I'm going to slide that off to the side, du. And then I still have the 1 on top, because that's over off to the side. I have 1 over, that sine theta is u, so u squared. That's my basic u sub. That's really just 1/9 antiderivative of u to the negative 2. Do not tell me that the antiderivative of that is natural log or something like that, right? That only works if it's 1 over u, not 1 over u squared. You have to rewrite that as u to the negative 2, then use your power rule, which means you add 1 to the power, then you have to do 1 over n plus 1 out front. So this should turn into, here's the antiderivative, 1/9, I'll just bring it. And then the antiderivative of that should be 1 over negative 1 u to the negative 1 plus c.
And that antiderivative subtracts.
Derivative subtract, derivative bring constant out, subtract 1. Antiderivative, add 1 to the power, and then multiply out front by 1 over n plus 1.
Right, gotcha.
This becomes, I'm going to put those together to be negative 1/9. And then u to the negative 1. I can leave it as u to the negative 1, or I can write it 1 over u. Let me write it 1 over u plus c. That's the same thing, right? All right, we've got to get from u all the way back to x. So right now, what was u for us? We made a substitution. U was sine theta. So let me write this over here. So this becomes negative 1/9 times 1 over sine theta plus c. And I could go work and figure out what sine theta is right now, or I could go try and figure out what cosecant theta is, because that's the same, cosecant, right? I'm going to go for sine. This is just personal preference. And where am I going to go to figure out what sine is? Yeah, my triangle. What was my original trig sub? What was it, 3 tan theta? That was my original trig sub. So I'm going to first create a ratio, get tangent by itself. So I'm going to divide both sides by 3. Does that make sense now? Remember, we're trying to make this, we're trying to isolate the trig function so that we can draw a triangle and have like opposite hypotenuse, whatever this is over here. Tangent is TOA, opposite adjacent, so x over x and 3 like that, right? And then you solve for this side. Solve for this side. I'm going to not show the work, but this will just become this, right? Because you'll do this squared plus this squared, and then you take the square root of it to get that side. So, and hey, look, it appeared, didn't it? Was that thing in the original problem? It was there. Yeah, it looks familiar, right? All right, so looking back at what we're trying to get here, how do y'all want to do this? Do you want to do 1 over sine, or do you want to write that as cosecant theta and just remember that, sine is, yeah, this is going to be hypotenuse over opposite.
I would just do cosecant.
Do that? Is that all right?
I do have a question.
This is hypotenuse over opposite. What's your question?
So 1 over sine theta is not secant theta?
No, that's 1 over cosine theta.
It just seems less intuitive.
Yeah, I don't make it up. Yeah. But the naming of these things I didn't make up. The way I remember it, and I don't know how I remember it this way or why I remember it this way, the way that I distinguish the two is that the cosecant has an S in the middle, and that's the one that goes with sine, and then the secant is just the other one. Yeah, so that's the way when I was learning it, that's the way I was able to.
I'm gonna write that
There's a bunch of other ways to do it. I mean, but, okay, here we go. So I'm ready for an answer here. -1/9. -1/9, and then we're going to go ahead and do hypotenuse over opposite. So square root of x squared plus 9 over x plus c. Thank you. We're done. I'm not going to take derivative of that because that looks a lot like the derivative we just did a second ago, doesn't it? I think it would work out almost the same. So I'm not going to differentiate that. Let's go do another example. Will you look at that while you just go get a drink real quick? Why don't y'all take a look at this? Start thinking about, at least at the bare minimum, trying to figure out like which of these you think it might fall into. And maybe you can discuss with your classmates whether or not you can just start going now, or if that 4 in front of that x squared is perhaps a problem. myself? I didn't unmute myself. It's okay. I'm unmuted now. And then that, right? What? Oh, under the square root. Oops.
How do you, okay.
What am I going to do now?
You factor out the 9/4.
Factor out the 9/4. Tangent squared theta plus 1. That's a trig Pythagorean.
That's a
Right. That turns into secant squared. Do you see we're kind of playing this same broken record over and over here? 3/2 secant theta. Okay, so turn the sum into a product, and then we could do square root of each one. Square root of 9/4 is 3/2. Square root of secant squared is secant. Yeah? All right, we've got everything set up.
Now you got to cube it.
Well, I'm going to cube it over there.
Okay.
Yep. I'm just going to rewrite everything now. How about we take that 8 that's on the bottom, bring it out as a 1/8, because it's just in my way. I don't like seeing it. It's probably going to cancel with something here, but I'm just getting it out of there for now. So I'm going to cube the x, right? I'm going to cube this, right? I got to cube this. So when I cube that, watch the way I'm going to do this. I'm going to write 3/2 cubed tangent cube theta. Now look, I could have cubed that. I could have turned that into, what, 27/8? I could have done that, but I'm going to leave it as 3/2 cubed because I know some things are going to probably cancel in the bottom. So that's the top, right? That 8 came out over, okay, the square root, be real careful here. The square root here is this piece there, right? That's that piece right there. But we have to cube it, don't we? We have to cube it. Do not forget that. So I'm going to actually write that down. I'm going to take the 3/2 secant theta, but I still have to cube the whole thing. I'll do that on the next step. Am I done? Dx, right? Dx. What's dx? Well, this, right? So I have a 3/2 secant squared theta d theta. Any questions here?
This is all going to be on YouTube, right?
It will be, yep. But the audio is not, I forgot to, when I came back in with my drink, I forgot to unmute until I just mentioned it a second ago, but you'll be all right. All right, so now, I got to clean this up. Let me do this. The 1/8's out here. I have 3/2 cubed tangent cubed theta over, when I cube the bottom, because there's multiplication, I'm going to cube this and cube that. So 3/2 cubed again, and then secant cubed theta. Then I still had the 3/2 secant squared theta. So all I did there, d theta, all I did there was just rewrote the bottom. And I only did that so we could just see that that's gone, right?
Were you intending to try to get that number to cancel them out?
I was hoping that, you know, either way, even if it was like third power and squared, I could cancel like 2 of them, or I just was avoiding the fraction. I'm just showing you like a different way of doing it. You could have just rewritten those as fractions.
Either way, it'd be 27/8 over.
Either way, it's gonna, yeah, it's gonna work out. All right, so on this one, that I can't cancel that out or reduce or bring it out. Nothing goes away, right? So that's gonna go out in front, which is gonna give me a 3/16.
Why is it that a constant can always just go out in front?
For the same reason that when you take a derivative, the constant comes for the ride, right? Same thing with antiderivatives. The constant does not have any impact on the antiderivative. It just scales it, that's it.
That's why.
We would have to go through the proof. We would have to go through the proof of the derivative, why a constant doesn't impact the derivative. And if we showed that, then it would be logical to go backwards. All right, what now? Secant squared reduces, right? And you no longer have that cubed, you have it to the first power, yeah? And on top you have tangent cubed. Nothing messes with that, right? So you've got tan cubed theta over secant theta, just one of them, d theta. Are we all on board? Are we all at the same place here? Any questions on where we are?
That 3/2 is also cubed.
This one and this one, yes? Yeah, because on the bottom, it was that whole thing cubed, right? Well, I erased, oh here. It was that whole thing cubed, so you have to cube both the 3/2 and the secant. All right, I do not see a basic u sub, because if I let u be secant theta, the derivative of that is secant theta tangent theta. I don't have that up here. And then obviously, if I use tangent, the derivative can't be in the bottom. So I'm going to go to sine and cosine again. Turn everything in terms of sine and cosine. So I have equals 3/16 integral. Okay, tangent cubed is sine cubed theta over cosine cubed theta. But all of that's over 1 over cosine theta because that's what secant is, right?
Cosine cancels.
One of the cosines goes away, right? You said cancel. So this flips up cosine theta over 1, right? That's what happens there. One of the cosines cancels. Let's just do it. Let's rebel. Okay, so that goes, and then integral. Okay, we have on top sine cubed. On the bottom, we have cosine squared. D theta. All right, that's where we are now. Whew.
You also have, instead of changing the sine cosine, you would like peel off one of the tangents.
You could try. I don't think it's going to help. If you peel a tangent off, that's not the derivative of something, right? Like if you peel one of those tangents over here, you have tangent theta, d theta. That's not the derivative of something, right? Like nothing nice, right? What do you take derivative of to get tangent? Yeah, right? So it's not, it's a natural log thing. So it's not going to be a basic U sub. But what about this one? I mean, is this one looking like a basic U sub right now?
Yeah.
If u is cosine, right? If u is cosine, what's its derivative? Sine. You have sine cubed. If you let u be sine, the derivative that's cosine, but it's down the denominator.
So you peel off and then
Peel off one factor of sine off the top. So take this, make that sine squared theta over cosine squared theta times sine theta d theta. Now I know you sit there and you're like, okay, do y'all see what I did? Just peeled one off, okay? And I know you look at that, you're like, well, that's tangent squared. No, don't go there, okay? Because we've peeled, that's the derivative of what? Cosine off by a constant, right? So I need everything over here to be in terms of cosine. And I'm in business, right? The bottom is already cosine. And that is 1 minus cosine squared. So if you use Pythagorean on the top, everything here will be in terms of cosine, and that will be the derivative. So I'm going to write 3/16 integral 1 minus cosine squared theta on the top over cosine squared theta on the bottom times sine theta d theta. The whole reason, again, I'm switching that over to cosine is because I'd like everything here in terms of cosine. The derivative of cosine is negative sine, so I see its derivative right there. I can do a u sub right now. I can also split that into two fractions if I want, but I'm going to do that actually on the next step. Run out of paper, yeah? So my wife, when we first met, she was real big on recycling, right? And if I've told you all this story, then I'm sorry. I know I haven't told this class, right? Maybe in my Cal 1. So recycling, you know, she'd get mad at me because I wouldn't recycle properly and all this stuff. And I tried to convince her, you know, like the cost of recycling, like the trucks driving around picking up the recycle and the cost to sort things and the emissions and all, you know. I tried to convince her, like, to me it's not as important. So I was explaining this in front of my daughter too, and my daughter's like, Dad, that's not right, you know, recycling is important. I said, this is what I told my daughter, I said, here's the earth, and here's the sun. Our sun is a main sequence star, so it has a lifespan, and it's going to do what all main sequence stars do when they die. It's going to expand, right? And when it expands, it's going to get so hot on Earth that basically everything's getting recycled. Everything's getting recycled, right? So the ultimate recycling is coming in some point in time. That's what I told my daughter. I probably shouldn't be telling that to a 4-year-old, huh? Should give her some more hope in humanity.
You told her Santa wasn't real either, right?
Yeah, and I said Santa was getting burned up too. He's at North Pole, he's going first. You know. He's going first. All right, you sub. No. Golly, come on. Why are we talking about recycling? Okay, cosine theta. Making a basic U sub now, right? Basic U sub. Oh, paper. You were talking about paper. That's what it was. I'm using all this paper. I think about paper. Don't worry about paper. It's done. All right, negative sine theta d theta. And then negative du is sine theta d theta. Rewrite the integral. 3/16 is on the outside. Everywhere I see cosine theta, I'm replacing it with u, right? And then my sine d theta is going to be replaced with du, negative du, sorry. So is that right if I just bring that negative out right now? There's my negative du, and that replaced this piece right here. So I've done that. Now I just replace all that. So 1 minus u squared over u squared. And that can be split into two separate problems because you have a single denominator. Which again, I could have done that earlier, but I just waited to get it to this point. So when I do 1 over this, that's u to the negative 2, minus, and then this over this is just 1. Wait, what? Split that into two fractions, right? 1 over this, 1 over u squared is the same as u to the negative 2.
Oh, okay.
And then u squared over u squared is just 1. We're almost to the antiderivative, right? So the antiderivative is negative 3 over 16. Okay, antiderivative of that is, we did that something similar to that a minute ago. This was negative u to the negative 1. That's what that is, antiderivative, right? Add 1 to the power, scale, minus what? So minus u plus c. If you have a question, let me know. We've come too far for you at this point to be like, okay, I'm lost now. I mean, if you have a question, let's make sure you understand, we can clarify it.
So we went from 1 minus cosine squared theta to 1 minus u squared theta over u squared theta over u squared. U equals cosine theta, du equals minus sine d theta.
Multiply both sides by negative 1 to make that a positive sine theta to match with what we have here. Then rewrite the whole thing.
Where's negative du?
Negative, I put the negative on the outside. So I could have left it in there, but I knew it was going to come out, so I just brought it out.
Makes sense.
Yeah? All right, now replace u with what u is, right? So this is negative 3 over 16, parenthesis. This is really negative. Ooh, this is tricky. Hold on. What does this mean? This is negative cosine to the negative 1, right? Wait, was it cosine? What was our u?
It was cosine.
Yeah, so it's cosine theta to the negative 1. So does that mean the inverse cosine, or does that mean 1 over cosine? 1 over cosine. 1 over cosine. So I'm going to write it like this. 1 over cosine theta. That's this right here, right there. Okay? I'm looking at this as being really negative 1 over u instead of negative u to the negative 1. Then minus cosine theta plus c. We're not done. Because now we got in terms of theta, we got to get back to x. But we're almost done. We're not done, but we're almost done. Y'all remember at the beginning of this whole thing when we first started with the first antiderivative stuff, and I said we're going to get, through these techniques, and we're going to get to this thing called trigonometric substitution. And it's going to be it's going to be drawn out. This is what they are. I mean, these problems take a lot of paper, a lot of time. There's a lot of room for error, so you have to be patient through it. I need to replace cosine theta, don't I? My trig sub was x. I'm going back to my trig sub. It was x is 3/2 tangent theta. Now look, remember I said that there's going to be some differences potentially, right? Difference in the way it looks. This is exactly an example of when that happens. Look, I'm going to try and get tangent theta by itself. So I'm going to multiply both sides by 2/3, like reciprocal. So I get 2x over 3. You'll see that? Just multiply both sides by 2, divide both sides by 3, and you get that. Yeah? I'm going to draw a right triangle. Theta. Tangent is opposite over hypotenuse. So the opposite side here for me is 2x, right? And the hypotenuse is, sorry, what did I say? I said opposite over hypotenuse. Opposite over adjacent is what I meant to say. So 2x over this one is 3. And then you can solve for this side.
And what is opposite over adjacent?
Tangent. Square root of this squared plus this squared. So 4x squared plus 9. Right? That is what we see in the original, right? But is that the thing that we did the trig sub on? What did we do the trig sub on? If you go back and look. Our trig sub was based upon this. 9/4. Right? We based our trig sub on that. So you would think you might see that in the triangle, right? We're actually seeing the original thing in the triangle. So that's why I'm saying it's not always going to look exactly the same as the trig sub. So
get to the hypotenuse being 4x squared plus 9.
a squared plus b squared is c squared, and then take the square root.
But that doesn't always happen. It's just
No, I'm just saying that this does not always match the thing that we did the trig substitution on.
It doesn't even match the original one technically because of the power of 3.
Well, yeah, I mean, yes, but if you look at that as a square root cube, then it does. We're almost done.
square root cube.
We're almost done. Our answer is, I want to put our answer right here. Our answer is, we think, negative 3 over 16. That's that constant. Let's go ahead and do parentheses here. All right, 1 over cosine is secant, right? Secant is hypotenuse over adjacent.
Because it doesn't have the S in the middle.
That's right. So hypotenuse over adjacent?